All right, good afternoon, everybody. Thank you for joining us. This is Sean here at Zyxel, and today I am talking about our Wi-Fi 7 access points. So these are some new models. The first one launched late last year, second one launched earlier this year. So we're going to start by talking a little bit about the technology, and then we'll talk a little bit about the two models themselves. This is a rather short presentation today. As we go through, if you have any questions, use the question and answer part of the Zoom interface to send those in. And depending on the question, I'll answer it as we go, or I'll hold off and save it till the end. So we'll get started here. We're talking about Wi-Fi 7 access points. So we want to spend a little time sort of explaining Wi-Fi 7. When it comes to Wi-Fi standards, we've been moving very, very slowly for quite a long time. And then we've suddenly seen sort of a bit of a run here as far as new products hitting the market. When it comes to Wi-Fi 6 products, that was our first foray into what I'm going to call the next generation of Wi-Fi technology. So unfortunately, Wi-Fi itself has been around since the end of the 1990s, and a lot of the issues and complaints people have when it comes to Wi-Fi just have to do with the fact that back in the 1990s, nobody was expecting Wi-Fi to be as ubiquitous as it is. No one was expecting so many users. No one was, envisioning video streaming and stuff like that. So because of that, there have been a number of issues following Wi-Fi or Wi-Fi in general. And I get into a little bit more depth on these on our Wi-Fi 101 webinars that I do every other month or so. So if you're more interested in some of the details on that, join our Wi-Fi 101 webinar. Um, but Wi-Fi 6 was really the first standard to come along that was designed to sort of solve as many of those issues as they could and to try out some new ideas for how to work around some of those issues while still maintaining backwards compatibility with older Wi-Fi devices. Um, so the first release of that was around September 2019, although really when it comes to business class products, you didn't see those until much later out on the market. Then back in 2021, you saw the first Wi-Fi 6E products. Those were first announced in the standard. So Wi-Fi 6E was just Wi-Fi 6, but expanded out from the standard 2.4 and 5 gigahertz to 6 gigahertz. So nothing changed other than the spectrum that you could use. So now we'd freed up 2.45 and 6 gigahertz. So you may ask, well, why didn't we support 6 gigahertz before then? And the answer was because in the US and around most of the world, 6 gigahertz technology required that you have a very expensive license to operate in it. It was only once the FCC opened 6 gigahertz up for unlicensed use um, that then we could expand Wi-Fi 6 to cover that area. And I just want to talk really briefly. Oh, I'll save it for one more slide. We'll hold off on that. And then, of course, there's Wi-Fi 7. The first draft of the spec came out in 2021, but you didn't see products, business class products, hitting the market until last year as the draft got more things nailed out or nailed down, fleshed out a bit, and then the chipset vendors to sort of catch up and be able to implement those features. So officially, Wi-Fi 7, the actual standard, has not actually officially been ratified yet, although it's pretty close. And we do expect there to be two releases. There will be a release 1 and a release 2. So all of the products that are on the market today are based on the latest versions of the draft, and hopefully will basically have little difference or be software upgradable to the release 1 official version, although no one will know until that actually gets ratified. So historically, Wi-Fi has had very little spectrum to play with. Because everyone needs to deploy it, you have to use unlicensed spectrum, and there really isn't a lot of it out there. There was some chunks of 900 megahertz available, but they weren't big enough to support, fast data transfer. 2.4 was our first foray. In North America, there was a little over 60 megahertz of spectrum available. 5 gigahertz gives us a little over 500 megahertz of spectrum available. And now with 6 gigahertz support, we've got a ton of spectrum that's available. As you can see here, there is more Wi-Fi spectrum available in 6 gigahertz than is available in 2.4 and 5 gigahertz combined. So because of that, by using 6 gigahertz, you solve some of the issues we have, which is one of the ways that we get faster speeds with Wi-Fi is using wider and wider channels. So obviously in 2.4 in North America, where there's only around 60 gigahertz of spectrum, you can't really use 40 megahertz channels without causing interference with your neighbors. There is one 40 megahertz channel available essentially. And then as soon as you add a second device, you get overlap and interference issues. Just going through it here, as we've increased speed, we went from 20 to 40 to 80 to 160. So as you can see here with 160 megahertz channels, 5 gigahertz only gives us 2 non-overlapping channels that you can use. 6 gigahertz gives us 7 non-overlapping channels. So you can have 7 access points operating on 160 megahertz channels, and you don't have to worry about any of them overlapping with each other and causing interference. 6 gigahertz now with Wi-Fi 7 also gives us access to 320 megahertz channels. So you get 3 non-overlapping channels at the maximum speed. So it becomes a trade-off. Do you want maximum speed or do you want, good coverage without interference? So it just depends on how many access points you're deploying and what your use case is. Generally, most client devices aren't going to be able to take advantage of those faster speeds. So it might make sense to use 160 megahertz channels instead. Now, the trade-offs with using 6 gigahertz are as Wi-Fi or as RF spectrum frequency goes up, range goes down. So you will require more access points to cover the same amount of area that you would cover with 5 gigahertz access points. So if you were able to deploy a network with 5 gigahertz access points, if you want that same coverage with 6 gigahertz, you may have to go up to 10 or 11 access points. Obviously, a lot of that's just going to depend on the environment and the structure of the building and obstructions that may degrade the signal. Another key thing when it comes to 6 gigahertz technology is 6 gigahertz is aimed as an indoor technology. So all 6E products and Wi-Fi 7 products with a 6 gigahertz radio can be used indoors without issue. You are not allowed to use them outdoors. You require special hardware for use outdoors because outdoor use is still using licensed spectrum. So the FCC has opened it up for unlicensed use outdoors with the 6 gigahertz spectrum. However, you have to play nicely with any existing 6 gigahertz licensed users in your area. So because of that, the access point has to talk to a third-party solution, which keeps track of where that access point is geographically and checks a database of other licensed 6 gigahertz users in the area and what channels they are using. And then that access point either has to eliminate channels that are used by licensed users in the area, or depending on how far away they are, reduce the output power of the channels that are available. So again, in order to use Wi-Fi 6 APs outdoors, you have to buy special APs that are able to talk to that third-party service, and you have to have a subscription with that third-party service. I believe currently the FCC has approved 7 different services. All of them have different business models and different costs. So at the moment, Zyxel does not provide any outdoor 6 gigahertz products. So that's sort of the background there as far as frequency goes. So what else does Wi-Fi 7 bring to the table? It brings, in theory, a lot faster speeds. So Wi-Fi 6 or Wi-Fi 6E had a maximum theoretical speed of 9.6 gigabits per second. Wi-Fi 7 increases that, in theory, up to 46 gigabits per second. It does this by using wider channels, and it does this by allowing more data streams to be used simultaneously. And obviously, the speed you can get is going to depend on the access point you have and the speeds it supports and the client devices you have and what speeds these support. So as I mentioned earlier, Wi-Fi 7 doubles the bandwidth that's available on 6 gigahertz channels from 160 megahertz with Wi-Fi 6 to 320 megahertz channels in Wi-Fi 7. Wi-Fi 7 also bumps up how wide of a channel you can use in 5 gigahertz. So in 5 gigahertz, you could use 160 megahertz channels. With Wi-Fi 7, you can use 240 megahertz channels, provided the AP and the client support that. That is a technology that a lot of the Wi-Fi 7 stuff out there that's at least available today does not support. We do, but a lot of the clients don't. So obviously, if your clients don't support it, it doesn't help today on your access point, but hopefully in the future, as the technology progresses and adoption rate increases, you'll see more client devices that can support it. We've increased the QAM, which is the modulation, which is basically how you cram data onto those radio waves. So we've gone from 1,024-bit QAM to 4,096 QAM, which gives you about a 20% data rate increase. And we've added support, Wi-Fi 7 adds support for what's called MLO, multi-link operation. It allows client devices to be able to simultaneously connect to multiple radios on your access point at the same time. So while you may have a Wi-Fi 6 access point that broadcasts on 2.45 and 6 gigahertz, your client devices can only connect to one of those radios at a time. When it comes to Wi-Fi 7, in theory, you could connect to 2 or more of those channels simultaneously. So your client device may be able to connect to 5 and 6 at the same time. And we'll talk a little bit more about that here on the next slide. There's another technology that's not on this slide here, and this is something that's expected with Wi-Fi 7 Release 2. So it's not available today, but it's something that will become available later. And that is the ability for AP coordination. APs to basically be able to talk to each other, share information, so that they can coordinate their channel usage and timing to try to reduce interference, possibly to help with offloading clients from one to the other. Another cool technology that we don't have on here, it's available today, is something called RU puncturing. So, generally when you're using a Wi-Fi channel, let's say you're using a 160 gigahertz channel, that is all 160 gigahertz are used as one big block. With RU puncturing, if we see another device nearby that's using overlapping channels rather than causing interference, we can actually split up that 160 megahertz channel we're using and basically not use that section of spectrum that overlaps with the source of interference. So you don't get the interference and drop packets that you normally would. So now we'll talk a little bit here about multi-link operation. So as I was mentioning before, traditionally, even if you have a multi-radio AP, your client device connects to only one of those radios at a time. 2.4 or 5 or 6, whatever it happens to be. With multi-link operation, in theory, your client device could connect to 2 or 3 of those radios simultaneously. Now, having said that, at the moment, I believe there's only one Intel PCI card that supports multi-link operation and one phone, the Samsung Galaxy S24 Ultra. Possibly the Google Pixel 8 Pro, but I don't think it's enabled yet. And another thing when it comes to this, at least right now, I am unaware of any chipset vendors that are looking to do all 3 radios at once. Most of them are looking to only do 2 radios at the same time. Why? Just because when you're talking about mobile devices, the more radios you have to have on, the more connections you have to manage, the more throughput you have to manage, the higher power utilization you need. So at least right now, most of the, or all of the mobile chipsets that I'm currently familiar with or that are in the roadmap are looking at just doing 2 at the same time. So what are the benefits of doing 2? 2 or more channels for this multi-link operation. So you've got a couple different benefits depending on what it is you're looking to do. So one of the things you can do is you can lower your latency. You can send the same data across these multiple links. So if one of those, some of that data gets lost due to interference from neighboring access points or other sources of RF interference, and causing those packets to be dropped on one radio, in theory, those same packets can come through on the other radio. So you don't have to have that packet drop and then the delay while you rebroadcast. Instead, the data comes through straight through. So this is very similar to SD-WAN. One of the benefits of SD-WAN was you send the same data over 2 different VPN connections that take different paths for the same reason. Since you don't have to worry about packets being dropped and rebroadcast, it reduces the overall latency, which is really good, especially for latency sensitive applications, such as doing voice over Wi-Fi. I fully expect when it comes to voice over Wi-Fi, you will see a lot of products in the future using this technology for that reason. The other reason for the other big benefit of doing this is you can increase your data rate. So instead of sending the same data over both streams, you send different data streams over both radios, and then they combine together for one faster stream. for those high bandwidth applications that you may have. So I was talking about it before. I forgot I had a slide here for it. So multi-RU puncturing, that ability to basically not broadcast on sections of the channel that you're using that may suffer interference from another RF source that's nearby. So instead of getting, in this case, 160 megahertz channel, you would cut out when there's a 40 megahertz channel from somebody else's access point that you don't manage that overlaps. You can simply drop that 160 megahertz channel to 120 megahertz and broadcast on both sides of the interfering channel so you don't get any interference. You don't get a latency hit, and you get a lot smoother connection going through. So that's it as far as the Wi-Fi 7 technology goes. Let's start talking about the products themselves. We've got two access points right now. Here on the lower end, this is our sub $200 Wi-Fi 7 cloud managed access point, the NWA130BE. So this is Nebula Flex. So you can use it standalone or managed through our free Nebula cloud. And just like all of our other access points out there, we have advanced cellular coexistence. So we have additional filtering that most of our competitors don't have that's designed to filter out interference from neighboring 4 gigahertz, or excuse me, 4G and 5G signals. So you say, well, when does that happen? So this is something that happens a lot in bigger buildings. So bigger apartment buildings, bigger office buildings, bigger hotels. The 4G or 5G signals have a hard time getting into the center of those buildings. So you get loss of coverage. So what happens is people use what's called a DAS system, DAS. And basically, it takes the signal that's coming from outside, gathers it into this DAS device, which then redistributes the signal into the building. So you have what sort of look like access points inside the building, only instead of broadcasting Wi-Fi, they're broadcasting LTE or 5G inside that building. So that way you have good, strong signal when you're inside that building. So if you've ever been inside, a big casino or something like that, and you still get good connection everywhere, it's because they're using a DAS system. And unfortunately, depending on the spectrum being used, you can get bleed over, especially when the IT team installs the regular access points close to the DAS system access points. So our filtering helps prevent that interference, keep things going through smooth. This access point is 3 radios. So it's got a 2.4 radio, a 5 radio, and a 6 gigahertz radio. All 3 operate at the same time. All 3 can support clients at the same time. And you can get data rates, wireless data rates of up to 11 gigabits per second. On the back side of this device here, you'll notice that we've switched from a round design to a rectangular design on our newer access points that have 3 radios. And that's because the rectangular design helps eliminate EMI issues between the different radio chips. You will notice here that we have 2.5 gig uplink ports on it. One of those ports is the data coming into your access point. It supports PoE to power up the access point. And then we've got another 2.5 gig port going out. So you can daisy chain this to another nearby port that you need access to. And then this has got our sort of standard these days Zyxel mounting bracket. So the bracket itself is designed to be able to be mounted to a wall, a ceiling, an outlet box, a junction box with a rectangular around. It also is compatible with our T-bar adapters. So you buy these T-bar adapters, they clip on to the T-bar of your drop ceiling. You mount the mounting bracket onto that, and then the access point slides in and locks in place. On the other end of things, we have our flagship. Oh, whoops, we got ahead of myself there. My bad. So this does use our standard RF first by design technology, where we put a lot of extra shielding into the board to help produce EMI. We also remove the antennas from the main board and put them on their own PCBA that's isolated from the main board. And this supports, of course, all the latest Wi-Fi standards here, WPA3 technology. It supports our CNP and CNP plus UTM services that are hosted on the access point itself, and supports dynamic pre-shared key. Oh, and I still haven't fixed that. I thought I had fixed that animation. So now we're jumping to our flagship product here, the WBE660S. So this is our higher end access point. You should be able to offer this for roughly $500. So this is our high end access point. So again, here's a little breakout here of that RF first by design technology that we follow. As you see here, the antennas are mounted separate from the main board itself. So some of the other stuff we've got going on in this guy here is this does support our smart antenna technology. So smart antenna technology, piggybacks really well when it comes to Wi-Fi 6 and Wi-Fi 7 technology to provide really good coverage, especially in tough RF environments. This access point has Bluetooth low energy built in, so it's able to work with some of your mobile applications that use BLE beacons to provide functionality. I know, for example, one thing that has been that we've done, our partners in Europe did, was a museum, and it uses this BLE Bluetooth technology to be able to locate where people are inside a museum, and for little handheld devices to automatically offer up self-guided tour information based on where the guest is inside that museum. And this guy here has got a 10 gig Ethernet port for the backhaul there. It does require PoE++ power in order to be able to power this guy up. So that's that 60 watt PoE technology. So you do need a switch or an injector that provides that PoE++ power to be able to power this guy up. Or alternately, it works with USB-C. So as long as you have a USB-C PD power source that supports at least 45 watts of power, you can use that to power the access point instead. I've tested it out. It works really great. You do have a 1 gig pass-through port, so you can still daisy chain these guys here. And something you will notice that's very different with this versus our other access points is generally with our access point design, we've got a metal heat sink that goes behind the main PCBA, and then the back of the housing has a bunch of vent holes. And the idea is to draw the heat off of the board and vent it out the vent holes. You will notice this guy here does not have any vent holes. So why is that? And that's because we've modified our design for this guy here. This back plate is not plastic anymore. This is now metal. And you see the fins right here, which are designed to help dissipate the heat. So because of the extra power that goes into this, this is an access point that in theory can support wireless data rates of over 20 gigabits per second. It requires a lot of power to do that, which generates a lot of heat. So this main board is designed to, or the back of the housing is designed to pull the heat off of the board and then vent it out. And similar to our other access points, we have a very similar mounting bracket, slightly modified to take into account the change in the back design on this access point. But otherwise, it's basically the same thing. It allows you to mount the access point directly to a ceiling or wall. It allows you to mount directly to a round or square junction box or to an outlet box. And then also it works with our T-bar clips if you want to mount it onto a drop ceiling. So this guy here is Nebula Flex Pro. So it can work standalone. You can manage it with our Nebula Cloud. It comes bundled with 1 year of Nebula Pro Pack with it. This guy here also can work and be managed by our USG Flex series of security gateways. So if you're looking to do local controller management, this is the guy you want for that if you're looking for Wi-Fi 7. So we'll talk briefly here about the smart antenna technology for the few of you guys who are maybe new and aren't familiar with it. So most access points are going to work with a single set of antennas that are optimized for the idea that you're mounting your access point on the ceiling and it's covering an area underneath it. So with smart antenna, instead of having one set antenna pattern, we have an array that can go through hundreds of different antenna combinations that take into account where your customers or where the client device is in relationship to the access point, as well as where sources of RF interference might be, and then tailors the signal pattern based on that to optimize the performance. So if any of you guys out there are former Ruckus guys, it's very similar to Ruckus's BeamFlex Plus. So this is just showing here, this is your traditional access point. It's got one antenna pattern. It assumes you're going to mount the access point centrally above the area to be covered, and then radiates the signal out in roughly an umbrella-shaped pattern. Anonymous, I'll answer your question just as soon as I'm done with this slide. Um, so just showing here, that's how things normally work. So with smart antenna, you've got that array that's able to go through hundreds of different antenna patterns in near real time to choose the one that works best based on where the client is in relation to the access point, but also takes into account other sources of RF interference. This, unlike beamforming, works great with mobile devices as they move around. It can support lots of different clients at the same time. It makes a huge difference in dense RF environments where you've got either a lot of users on a couple access points or you've got a lot of access points crammed in the same area. So it really shines in smart classroom type environments, meeting rooms, expo centers, conference centers, anywhere where you've got either a lot of people in the same area. It makes a huge difference in real world performance. So Anonymous asked, will the Wi-Fi 7 access points support multiple networks with a single AP? And yes, they do. All of our business class access points support multiple SSIDs. So that's where you can set up, multiple different networks, each with their own unique broadcast SSID, their own unique security settings. And then you use VLANs out of there to be able to connect to multiple networks to isolate them from each other. We also do support dynamic pre-shared key, DPPSK, which allows you to use one broadcast to SSID. And then based on the pre-shared key the user uses to authenticate, it will then apply VLAN rules based on that. So it gives you the same benefits of enterprise security, where each user has their own unique username and password, where each user just has their own unique password. They log in and automatically get put on whichever network they belong to, rather than having to have multiple SSIDs being broadcast. So where are the areas where Wi-Fi 7 shines? So to be honest with you, there are not a lot of Wi-Fi 7 clients out there. Apple's iPhone does not support Wi-Fi 7 yet. It's just 6E. The Galaxy S24 series, the Ultra, supports Wi-Fi 7. The S23, in theory, the chip in there supports it, but I don't believe Samsung has released an update that enables it. Google Pixel 8 Pro supports Wi-Fi 7. So when you're doing this, for the most part, you're probably doing this to future-proof your network, right? Your customer's in the process right now of deploying and speccing out a new network, and they don't want to have to upgrade that network, um, 1 or 2 years from now as more Wi-Fi 7 clients become more broadly available, right? As soon as the iPhone comes out with Wi-Fi 7, everybody's going to be bugging their IT guy, hey, why can't I connect at Wi-Fi 7 speeds to your network, right? So this is get the hardware if you're deploying it today so that you don't have to upgrade it and tear it out in just a couple of years. Some of the main benefits here: high density locations are great areas for it because of that 6 gigahertz. You've got a lot of non-overlapping channels you can play with on 6 gigahertz to avoid those things. There's some other technologies in Wi-Fi 7 and Wi-Fi 6, which also help with high dense deployments. Another area where we think that Wi-Fi 7 is going to shine, again, because of that 6 gigahertz radio, is when it comes to business class mesh networks. So you might remember, it was a long time ago. We'll call it a decade ago. So I'm old. I think it was probably a decade ago. There was a big push to do mesh in business in enterprise. And it kind of petered out and didn't go anywhere because the quality of the connections wasn't there. We do see mesh, though, having been embraced greatly by home users and internet service providers at home. And we think that with Wi-Fi 7, you now have the ability to do a mesh in a business class environment, in a business environment with business class service, thanks to that 6 gigahertz radio, right? There's not a lot of products out there using 6 gigahertz. You've got a lot of spectrum, so you've solved a lot of those interference issues that have plagued business class mesh networks in the past. So since most of your clients are using 2.4 or 5, they will still use 2.4 or 5 to connect. And then you use the 6 gigahertz radio to provide a super fast mesh backhaul. So allowing you to deploy access points wherever you may need them and not needing to worry about running Cat 6 data connections to those access points. So this is one area where I think you'll start seeing a lot more mesh being used in business, because tri-radio 6 gigahertz really makes it a proper business class type service offering that you can add. And then the other area here is high bandwidth applications. One of the problems, for instance, you always see people talking about, oh, let's do VR, but stream it instead of having to have a wired connection or to build heavy duty hardware into the headset itself. You also see people doing video streaming and things like that. And the way it works now is, because the bandwidth isn't there, you either have to do a hardwired connection or you do wireless, but you have to compress the video, send it, and then decompress it. So you get added latency, which is really sucks for VR. You also get some image degradation. So with Wi-Fi 7 and speeds of, wireless data rates of 20 gigabits per second, which are probably giving you close to 10 gigs per second actual throughput, and other Wi-Fi 7 faster technology that may come out here. Again, in theory, the maximum data rate's up to 46 gigabits per second. It gives you the ability to be able to stream raw high definition video with no real latency, because you don't have to worry about needing to compress and decompress the video. You're essentially going to get similar latency as you would with a wired connection, but with the freedom to move around and roam wirelessly. So that's another area where I think Wi-Fi 7 is going to have a big play. So with that, guys, that ends today's webinar. Again, if you've got questions, send them in now using the question and answer part of the interface. While I wait to see if any come in, I just want to highlight here, we do have a YouTube channel. It is called Zyxel America channel. Now, Zyxel has lots of different offices, and they each have their own YouTube channel. So North America is called Zyxel America channel. Most of our webinars are recorded and will be posted up within 24 to 48 hours. Onto that channel. So if you missed a webinar you wanted to see, or you want to share it with somebody, that's where you would go to find it. We also have some best practices videos on there, video case studies, and other data that we put onto that channel for you. And then, of course, as always, if you want to connect to us on LinkedIn, where we are known as Zyxel US channel. Again, just like with YouTube, there's a lot of different Zyxels on LinkedIn. So Zyxel US channel is us here in North America. I'm not seeing any questions that have come in, so I'm going to go ahead and end today's webinar. If you do have something that comes up, you can email me directly. It's Shawn R, SHAWNR at Zyxel.com, or just reach out to your sales contact, David, Andy, Jacob, send them the question, and they can forward it to whoever the right person is to get you the answer. I appreciate you coming out today and joining our webinar. I hope to see you at one of our future ones. Thank you.